In this video, we will be demonstrating the benchtop subsonic wind tunnel, the AF1125 from Techquipment. This is an ultra-compact teaching wind tunnel that offers a complete system ready for experimentation into the principles of aerodynamics. Learning the basics of aerodynamics such as lift and drag are important for understanding the theory of flight in aircraft, but are also important in the design of other vehicles such as cars, boats and even the likes of wind turbines. The benchtop subsonic wind tunnel allows you to learn more about lift and drag, as well as principles such as flow past bluff and streamlined bodies, and learn about pressure distribution around a cylinder. It's a complete package that fits neatly on a bench or table in even the most compact engineering teaching labs. As you can see, as wind tunnels go, this is exceedingly compact. Let's take a look around the benchtop subsonic wind tunnel. The main wind tunnel is 1,850 millimetres long, 560 millimetres wide, and taking into account the exhaust duct, it's 1,040 millimetres high. The working section itself is 125 millimetres by 125 millimetres and is made from clear acrylic. You can see here holders that support the wind tunnel models on the side and the floor. All of these main wind tunnel elements are mounted on a steel frame. In addition to the main wind tunnel, there is a separate control and instrumentation unit as shown here. Let's come back to that in a minute. First, I'd like to show you the main part of the wind tunnel in detail. Over here we have the aerodynamically designed effuser, where air is drawn by suction through the honeycomb flow straightener. It's important to get the flow conditions right in order to get accurate results in the experiments. Now the air is running linearly, it enters the working section where the models are mounted. The air then passes through a grill which is in place to protect the fan from damage by loose objects. Once passed through the grill, the air moves through a diffuser to a variable speed fan that we have here, which creates the force that pulls the air through the wind tunnel. The air leaves the fan, passes up through a silencer unit and then back out into the atmosphere of the room. So we've sorted the airflow, we have the conditions right for doing experiments. Next we need to think about measurement to get accurate and repeatable results. Up here above the working section there are two pitot tubes that connect to the liquid manometer so that you can analyse pressure at different positions and calculate the airspeed. In the floor of the working section there are two tappings to measure the static pressure upstream and downstream of the working section. We're now going to show you the two-component balance that attaches to the side of the working section. This has integrated instrumentation that connects to the control unit to measure the drag force and lift force in newtons of the models during experiments. Should you be creating your own 3D printed models, you can also mount these underneath. Three experiment models are included: the NACA 0020 aerofoil, a bluff body known as a flat plate, and a cylinder with pressure tapping. Now let's return to the control and instrumentation unit. This is a freestanding unit but needs to stay close by as the power cable connects between the two. Within the box there is a controller with an electronic drive that powers the fan. These buttons and knob control this, with the obvious on and off buttons and a fan control knob for varying the fan speed, which can be left in a chosen position to maintain a constant speed. It also includes an emergency stop isolator. The display is for showing the drag force and lift force in the newtons from the two-component balance. The benchtop subsonic wind tunnel is part of an extensive teaching range of teaching products for understanding aerodynamics from Techquipment. For more information, click on the links in the description box below, and why not watch more videos on other subsonic and supersonic wind tunnels from Techquipment. You may also find the aerodynamics playlist on the Techquipment YouTube channel worthy of watching. Thank you for watching.